I wonder who that could be.
Oh, hey Frank.
Oh, hey Nick, what's up? Yo, why do you have your physics textbook?
Oh, I was just trying to have some physics fun, bro.
Oh, really? Well, that sounds swell.
Oh,
Like,
yeah.
No,
I was just wondering, I was just in the neighborhood and wanted to know if you wanted to study for our test tomorrow.
I would love that. Yeah, come on in, Nick.
Thanks, bro. All this physics studying is making me need some tissues, eh? Do you got any?
Yeah. Right, man.
Thanks, bro.
No
Yeah, to
problem.
wipe away all the tears.
I don't think this is going too well, man. We're gonna need these tomorrow for the test.
Yeah, bro. Like, doesn't look like we're getting too much done. But like at the same time, like we're gonna need as much time as we can get on the test. So like, we're gonna need to find out a way to pull these out without wasting any time.
You mean like? Are you thinking of nothing? Maybe we should build a deliberately complex contraption, which in a series of devices reacting in a domino-like chain will perform the tasks that we want it to at the end.
Bro, yeah, that would stone 2 birds with 1 kill.
Don't you mean kill 2 birds with 1 stone?
Nah, bro, I know what I'm talking about. Trust.
Fair point. Let's get to it. Cheers to that.
On this side. It works. No, oh my god. So Frank, how are we gonna get the tissue out of the box?
I'm glad you asked, Nick. So, with our Rube Goldberg, obviously. So, our Rube Goldberg starts right here and starts with a phone. So, it starts with the phone at the top of the ramp, which, after getting a call reminding us that we have a physics test tomorrow, it will slide down the ramp, hit this first box, which triggers a domino top-over reaction. This will then hit a ball, which, with pendulum-like motion, will swing and hit this ruler, causing this to almost turn like a lever, knocking this glue stick off and allowing this to free fall back, hitting the other ball in the Newton's cradle. Through this, the last ball will hit this domino, and this will cause another set of domino chain reactions. And at the last point here, we get at this lever here. Once this lever is struck down, on the end we have a bucket that's full of little weights. After this, once it's hit, these weights will top over, go through the funnel, and hit this book right here. And this book is attached to a weight, which is then attached to the button of the fan. And once this button is pressed down with the weight of the die, the fan will turn on and it will power this cart. This cart has a sail attached to it, so it will pick up speed going down, and it will hit this soccer ball, which will then roll down the hill and back onto this book, which will act as another kind of lever Once it goes this side down, the force will go up this way and it will pull tissue out of the tissue box.
Wow, it's pretty gnarly, Frank.
Thanks, bro.
So in the beginning, our Rube Goldberg project starts with the phone falling down, and this is an example of many different types of energy conversions. So first, we have electrical energy stored in the battery, which is then used to cause the phone to vibrate. This converts the electrical energy into both thermal energy and kinetic energy. Now this causes the phone to overcome the static coefficient of friction, causing it to then fall because there's less of a force going this way. Now, as the phone goes down, it converts its potential energy as height into kinetic energy going down, and into a little bit of heat energy because of friction. So then it hits the card box, which acts as the first domino, and then these all use their potential energy to convert into kinetic energy going this way, which hits into the golf ball, which then swings across, using again more potential energy, dropping in height but gaining potential energy. So then, if we look at this area, as it hits the ruler.
It's cool. It's transfer kinetic energy. It's cool.
97?
About.
Anyway, so the golf ball will hit into the ruler. The ruler will act as a lever, kind of moving across the fulcrum here, hitting into this, transferring the energy going this way into more energy going this way. So then this will drop the ball, which converts the ball's potential energy with its height into more kinetic energy, going through here. And again, more potential energy in the books is stored and converted into kinetic energy. Then if we go down here to the lever, the hockey stick here, we can see again there's another simple machine, another lever used here. And we use this to push these down. So we can see the fulcrum here, which is what the lever turns onto. Then the weights here, the dice and the marbles, use their potential energy to gain kinetic energy. They convert it to hit the weight down here, which causes the fan to turn. Now, the fan is another example of many types of energy conversions, because originally there's in the power plant there's nuclear and chemical energy, which is converted into electrical energy. It comes through the wire, comes here, which is then converted into kinetic energy in the fan, which pushes this cart, which applies force on the cart and then applies a force on the soccer ball, pushing it. And then finally, we see our final lever here, our final simple machine. The soccer ball applies a force downwards here, which then causes this downwards motion causes a motion upwards to pull the tissue out of the box.
Wow, fancy stuff.
Thanks, bro.
This is take number 65.
6.
6? Okay,
66.
66. Yes! Yes! Come on! Yes! Come on! This problem occurred because the phone missed the domino at the start.
It's gonna move.
This was solved by making the incline steeper, increasing the potential energy to convert it to more gravitational kinetic energy.
Can't even get past step 1.
With this problem, the domino didn't hit the other domino ahead. This was solved by moving the previous 2 dominoes more to the left to allow more contact and more chance to get the other one started.
No!
In this problem, the marble didn't hit the weight hard enough to fall onto the fan button. This is solved by resting the weight on top of the fan button, and we place the book on top of it to increase the chance of getting contact, allowing the fan to start.
So the problem with this take is that the Newton's cradle didn't trigger the next set of dominoes. We ended up solving this by moving the first domino closer to the Newton's cradle so that the Newton's cradle would apply more force onto it and that force would apply to the second domino.
Take.
The problem with this take was that the ball missed the lever pulling the tissue out of the box. So that we had a 3-part solution to this. First, the platform, the ramp that the ball went down, we bent that to funnel it towards the lever. Second, we used a heavier ball to apply more force on the lever. And third, we put a book on top of the handle end of the lever to give more chance that the ball would hit the lever. So the problem with this take was that my phone didn't accept the call of service provider issues. So our short-term goal was to switch to Frankie's phone. Long-term goal was to get a new phone. Haven't gotten there yet.
Bro, that was a pretty impactful 3 days, man.
Yeah, bro. Wait, what was the point of this again?
I don't know. Anyways, I'm going.
Wait, where are you going?
Nowhere special.
Where's that?
I'll show you.
Wait, did we miss the physics test this morning?
Nah, it doesn't matter.
True. Alright, let's head out.
Yeah.
Wait a second. Don't you live here?
I do. Man, whatever. Come on. Like,
I feel like we need something else for our test tomorrow. I don't know what though.
cheers to that.
Bro, like church history and physics are the same thing, like trust.